This video is titled Workload Modeling. In this video, we will cover the 3 steps for workload modeling, which are creating interfaces, and matching resources to interfaces, and finally adding workload values to all the task nodes performed by an operator. After we go over those 3 steps, we will also show you how to generate built-in workload reports. As usual, we'll begin by doing our versioning by copying our previous mission and then pasting that mission to get a new version, and we'll update the description. Once we've updated the description for our new version, we'll go back into the network diagram for this new system, close those tabs from previous uses. And our first step is to create interfaces. So interfaces are literally that. They are the physical items that the operator will interact with in order to accomplish their task. To create an interface, go to your analysis tree and find the RI pairs, which stands for Resource Interface Pairs. You can expand that, and then you can expand the Interfaces module. Note there's already a default interface called Crew Station. Unlike our default operator, we are not able to rename the Crew Station default interface. If you'd like to create a new interface, you right-click on Interface, and then use the left mouse button to select Interface. You can then double-click on this new interface and rename it, and we're going to go ahead and rename that to be ATM. When we click out of there, we'll see that we now have an interface called ATM. I'm also going to go ahead and add another interface, which I will name Cell Phone, because I know I might want to use that in a subsequent model, so we'll go ahead and create it now. So once you have your interfaces created, you can now match your resources, which are your mental resources. We've got auditory, cognitive, fine motor, gross motor, speech, tactile, and visual. We've got these 7 mental resources, and we can match these resources to those interfaces. To do that, we're going to double-click on the RI pairs. And you can expand your columns if you need to in order to be able to read them. And what you want to do is you want to check for each of those interfaces, check mark any of the resources that you think might be used when interacting with that resource. So you want to be as inclusive as possible. So if you have any doubts, you can check them all. With an ATM, we might have auditory beeps, so we'll go ahead and select that one. There will be some thinking involved. Fine motor, which is what you would do with your fingers, as opposed to gross motor, which might be whole body movements. Not really going to be doing any of that with the ATM. Speech, we're not really going to be talking to the ATM. We might have some tactile when we're touching it, and we're definitely going to have some visual. Then we can go through the cell phone and go ahead and assign those as well. There is some speech involved there. You may or may not use all of these, but now they're available for you in case you do use them. And then I'm going to go ahead and leave the crew station blank because I'm not using the crew station in my particular model. So this was on the Channels tab of the RI pairs. You'll also see that there's a Conflicts tab. I recommend that when you run your model, you do it the first time without any of the conflicts or interference. What this allows you to do is to capture that when you're using multiple channels at the same time, there may be extra workload that results from the fact that you're just using both those channels at the same time, and they have some kind of interference or conflict with each other. So we're going to leave this blank for now, but then we'll come back and revisit this tab and assign some of those interference values. So we have now created our interfaces and we've assigned those RI pairs, and we're now in a position where we can actually add workload to our task network. So I'll go back to the network diagram and I'll go into a task that is performed by the human, since that's where workload will occur. And from there, I will go ahead and select the Workload Demand tab. Once I'm here, I need to then select which interfaces are actually used. And for Insert ATM Card, I am using the ATM, so I'm going to select that particular interface. And you'll see that now what was previously unavailable, we now have any of those particular resources that we identified as potentially in use with an ATM are now available for us to input our values. So we can go to a particular task. We want to think about this with inserting the ATM card. They're probably not listening to anything. There may be a little bit of thinking. If you want to, we can go in now and look and see when you click at the ellipsis. Let me do that one very quick. If you click on the ellipsis, it will actually bring up your VACP values that are associated with that particular resource channel. So there's not a lot of effort going on there. Fine motor. Right, this might be a little bit of like a manual tracking. We're trying to align. So this is an alignment task. We're trying to align the card with the slot. And visual again is another alignment task, right? So I've gone through and I've assigned some workload based on the particular task itself, and this is a complex process in and of itself. So the nice thing is that we do have these tables that help us to identify different potential values, and for the most part they're pretty mutually exclusive, and so it's usually relatively easy to differentiate these particular items. But sometimes when you're thinking in the context of your particular task, you may actually have to really spend a lot of time and deliberate on these, and this is definitely a part of your modeling process that you're going to want to spend some time doing verification with subject matter experts, other people that are either very familiar with VACP or perhaps also very familiar with the task, so you can make sure that you've really identified the right workload values. So I've selected values from the chart, but note that you can also just type whatever you want directly in, and IMPRINT will accept your own personal values that you've created, although I would shy away from those unless you've got a good reason for creating the values yourself. All right, I'm now going to take a little bit of time and I'm going to populate the other tasks that are performed by the human in this one. So you'll note on this one I have selected for entering the amount withdrawal that it's just an alternative selection, and I've got for my fine motor that it is a single button push. What I'm thinking here is that the person is using one of those fast cash options, so the choice that they have to make is, do I want to take out 20, 40, 60, 80, right? So it's giving them a defined set of choices and they're selecting one. So this one was kind of complicated to take money from the slot, because you have to make a decision: are they just taking the money, which I've mostly done here, or are they actually going to take that money and also count it too, which of course is a slightly more complex process, especially if they're not as comfortable with counting, right? So they may be double checking the system to make sure that they got the correct amount. All right, so I've assigned workload now to all of these particular items. And in a previous video, I also assigned task times to all these items. You will need both workload values and task times in order for IMPRINT to do the workload calculations, because it is calculating workload over time. So I'm now ready to see what kind of reports I can generate regarding workload from the model. I'm first going to go ahead and check the model for errors, always a good idea. You can do that by hitting the check errors button or under execution, that's the first option there. We were successful, there were no errors. Now I'm going to go into settings from the execution menu, and here we can see that we have a couple of different things that we can set. We can set the number of times the mission is to run. So it starts off only running one replication, but if you want to see that variability over time and the variability that's caused by the different probabilities and probability distributions in your model, you're going to want to run multiple missions. We can also set the random number seed. So this is the seed that's used to generate the random number stream, and then the various values in the random number stream populate the random aspects of your model. And we can also set here whether or not we want to use workload strategies or those performance shaping functions if we were to have any of that content built into the model, which currently we don't, so we'll ignore those. Right now we're going to go ahead and leave it at just one replication to run, and we'll go ahead and leave it to the default seed. So once we've got that, we can then go to execution again and hit begin simulation. You'll see down at the bottom, it will tell us that it was beginning the simulation. It'll start to run it, and then it'll print out when it's completed how much time in real time it took to run the simulation, and then also how much time, clock time. So here we had 210 seconds, so this transaction took us, 3.5-ish minutes to complete. So that's not too bad for the time spent at an ATM. So once we've run the mission, we can now get those reports. So we'll go up to reports and go to operations results, because this is an operations model. And here we'll see all of the reports that are built into IMPRINT. You can check off any of the reports you're interested in. I'm going to go ahead and check off the operator workload detail, the operator workload summary, the operator workload chart, and the data for that graph, the operator workload graph. So I can see those different workload reports, and I'll hit OK. When I do that, you'll see down at the bottom it was running the model, and then it's going to come up and it's going to ask me, of my operators, which ones do I want to graph? My companion is not really doing anything right now, so I'll go ahead and get rid of the companion, and I just want to see what's going on with the customer. Alright, and then it will open up in Excel a single workbook that each sheet has the different reports that you selected. So we've got our detail here, our workload summary, our workload graph, and then the data that's used to present that graph. So here is our workload summary. We can see here each of the clock times in the model, and as you can remember from the model, there's really only 5 events that the person is actually conducting. So we've got when the clock starts, and then we've got basically those 5 events. We can see at what time they happened and the total workload for them, as well as how that workload is split across the various channels. We can go into the detail, which actually tells us the task names. It gives us a little bit more fidelity on that one, and in addition to the overall resources, it actually breaks out those particular channels by the individual interfaces that we had if we wanted to break down and see which interface was causing them. Of course, right now the cell phone doesn't have any things happening with it, so those are all 0. You'll also notice that it also lists those tasks where no workload was associated, right, for the system. So it groups them and shows us everything that the customer has done, and then it shows us everything that the system has done. You can also use this particular report for debugging if you wanted to check the timing of when actions are happening. You can use this to check the timing of when your operator is doing certain tasks and when your system is doing certain tasks. I'll now turn to the graph. So this actually shows us how our workload varied over time through the model. And this will gives us a sense of what the maximum workload is, and you kind of get a sense of which activities we're spending a long time on as we proceed through this model. And then we also see here is the data that was used to generate that particular workload graph. So the nice thing about the data is that now that you have the specific information, you can also use it to do your own, well, with all of these, because they're in Excel, you can use it to do your own manipulations. So if you wanted to calculate your own time per system workload average, you could do that. Note that we show here, shows us the random number seed. Note that we're only seeing one replication. For the workload reports, even if you run the model multiple times, so even if you ran it for 30 replications, your workload data is only going to be given to you in the reports for that first replication. So if you would like to capture your workload across many replications, currently you would need to run the model separately each time, and you could change the random number seed for each of those different iterations that you run so that you do get that variability in your model outputs. All right, I'm now going to go back into the model. I'm going to go back into that conflicts tab and go to conflicts, and you can see that you can go through and you can actually type them in manually, or you can select a row and then hit auto. And so you can then look across this particular item and answer some information, and it will use predefined values from the literature regarding the relative conflict. So the auditory with the ATM, that to me is just a tone, right? It's not verbal information. The ATM is not necessarily talking, although it could talk. But in this case, we've just got an ATM that beeps at you when certain things occur. So I'm going to say that's audio. I'm going to go to the cell phone. The cell phone will carry verbal information when we get there, so I'll mark that. The ATM is spatial. Yes. For that cognitive information. There may be some spatial aspects to it. Cell phone is spatial. That. Maybe, maybe not. So some of the cognitive things that you're going to be doing with the cell phone, a lot of that's just going to be talking and you're not really doing spatial aspects, but you may also be physically interacting with the device. So I went ahead and put that it is. The fine motor for the ATM, yeah, you might be typing in numbers like your PIN number, so that's verbal information. All right, so now that we've assigned these conflicts, we can actually go back and rerun the model. And so fast you almost don't see it happening. And so you rerun the model, and now we can generate those same reports. This time we've got it with the conflict information. And I'll go ahead and just go to the graph, and you can see here now we've got a very differently shaped graph. It's still the same random number seed, but now we're accounting for the conflicts that are happening between those different channels. And so let's see if I can actually put these side by side for you here. So you can see that see that you've got an instance where this is the one here without any conflicts. The highest value is between 15 and 20, and now we're hitting above 40 when we've added in the conflicts. And you can also see that that middle task, where you're actually doing the decision making, actually has much higher workload, whereas the original tasks, they're not really changing in workload with the conflict values the way this middle task is. And that middle task that we have is right, entering that amount to withdraw. So it's making that decision. So, all right, we'll go back to IMPRINT. So that's our interference. Like I said, I recommend that you run your model both with interference and without interference, and that what you want to do is you want to go back and whatever verification and validation process you have for workload, you want to see which of those two produces outputs that make the most sense for your particular context. Okay, so in this video, we covered the 3 steps you need in order to do workload modeling, which is number 1, creating those interfaces, then 2, matching the resources to the interfaces, and 3, adding those workload values to all of the task nodes performed by an operator. We also looked at how to generate built-in workload reports in IMPRINT,